Hi, in this video we're going to look at answering question 3 of the Core 2 Practice Paper 1, paper that I've made for AQA, but it is suitable for the exam boards. As ever, if you need any more information or have any questions for me, contact me on Twitter. Okay, so this question is talking about a geometric sequence. Okay, so we've got this geometric sequence here. It says the second term is 9 and the fifth term is 1.125, and we've been asked to work out the value of the common ratio. Okay, so let's have a think about what we mean by a geometric sequence. Well, a geometric sequence starts off with the first number, we'll call it A, and then each time the first number is multiplied by this common ratio R. So the second term will be A R, which actually we know the value of. We know that that's 9. I'll write it in underneath. Then the next time we multiply it by R again. So the third term would be AR squared. And the term after that would be AR cubed and AR to the 4, and so on and so on and so on. Now, I've said that this is our second term. This would be third, fourth, fifth. Oh, we also know our fifth term as well for this that we're doing here is 1.125. Now, if we're wanting to work out what R is, well, we've got these two bits of information. We know that AR is 9, and we know that AR to the 4 is 1.125. In order to eliminate some of the things, we don't really care what A is. We've not been asked for A. So if we set this out as AR to the 4 divided by AR, then we'd have 1.125 divided by 9. If we look at the left-hand side, can we see that the A's would cancel, and we'd be left with R cubed. And if we do this calculation on the right hand side on our calculator, this comes out as 1/8. And so then we can just cube root it, which gives us that R equals a half. Okay, so we've worked out what the common ratio is there. Now, that's fairly straightforward. I think once you get into your mind what's going on with this common ratio. Okay, so we've done the first part and we've said that R is a half. Can we work out the second part in the small space I've got left? I think so. There's only 2 marks, and actually we've got quite a lot of the information here already. How would I get from 9 back to just A here? This was AR. I want just A. Well, A times R was 9. Let's have a little think then. So I'll just do it as a little bit of an aside here. AR was 9. I know what R is now. So A multiplied by a half, or A over 2, is 9. That must mean that A is 18. Okay, and I've done that part as well. Good. So that, oops, made a mess there. So AR, A is 18. So we've now got A and R. From there we can do pretty much everything else. So let's look at part C. We'll do that on the next page. So part C says the sum of the first 10 terms. Again, we can use a formula that's in our formula booklet here. So we can say the sum to however many terms is A multiplied by 1 minus R to the n, all divided by 1 minus R. I'm just going to split my page because I'm going to do the other part on the other side. So we're interested in the sum to the first 10 terms, where A is our first number, 18, 1 minus, and we've got a half, is our common ratio, to the power of 10, all divided by 1 minus a half. And I can put this in my calculator. I don't need to do anything else. Let's just have a little look. We want 3 decimal places, so I'll type it in my calculator and see what I get coming out, and then we'll have an answer. So I've got 35.9 965. Okay, so I've just done that straight on my calculator. The next part is the sum to infinity. And again, you're given this information in your formula booklet. So this is when we say sum to infinity is a over 1 minus r. You can only do this when r is between 0 and 1, either positive or negative, but between 0 and 1. Because it then starts to converge to a single point rather than just getting bigger and bigger or in either direction, positive or negative. Okay, so let's have a look then. R is a half, so there's no reason why we can't do this. So the sum to infinity is A is our first term, 18 divided by 1 minus a half, which is a half. So we've got here 36. Okay, and that's it. We've worked out A, B, C and D. Okay, so in this, for geometric series, we're remembering that the formulas, the key formula, are given in the exam. Okay, so you don't actually need to know too much other than the fact that maybe what it looks like in terms of the terms. Looks something like this, where this is the first term, second term, third term, fourth term, and so on and so on. Okay, that's probably quite the useful thing to do. Sometimes we also see it listed slightly differently with sigma notation. I actually haven't done any sigma notation questions in this paper, but I will do in the future. So make sure that you know what this kind of thing means here, where we've got sigma and then some notation after it. We'll talk about that in more detail later, and you can add to your card then. Okay, so hopefully you've got this question right, and I will talk to you again soon. If you need anything, get in touch. Okay, bye.